Thank you very much for the invitation to be here. I'm thrilled to pull a couple of threads that we've heard several times throughout this morning, and in fact over the last couple of days, regarding new developments in alternatives to conventional animal agriculture products. I'm in agreement with Richard a couple moments ago saying this is perhaps one of the most exciting areas where we'll see a lot of activity in the coming months and years. My disclosures, I have none. I work for a nonprofit organization, and we are entirely supported by philanthropy. We work with a lot of startups and established industry partners, as well as investors in this space, but we don't receive any revenue or equity from those interactions. First, I'll kind of frame the problem statement here, and I'm sure that a lot of this won't be news to anyone in this room, but the solutions that we're talking about are quite novel, and so I think that's where the excitement comes around, and I really want to delve into those opportunities from a technology perspective. So here's the fundamental challenge we're faced with, is how do we meet growing demand for meat when we're looking at somewhere from 50 to 70% increased projected demand looking towards 2050 across all different animal products when we know that it is so resource intensive. Here's one of my favorite figures that shows the current demand of agriculture and animal agriculture in particular from a land use perspective, which as we know is a resource we can't really change much. Of course, we've improved efficiency of all forms of agricultural production very substantially, but we start to run into kind of cold, hard limitations when we look at the resource burden of animal-derived products. So as you see here, we're already using about 50% of habitable land for agriculture. More than 3/4 of that goes towards either feed for livestock or grazing lands for livestock, even though those products are contributing the minor fraction in terms of our protein supply and our calorie supply. And the reason for this is it comes down to kind of fundamental thermodynamics. You've got, say a chicken as a black box system. All animal products are like this. You're funneling calories into the system in the form of feed. Almost all of those are being expended in processes that are not useful to the end consumer, maintaining body temperature, moving around, thermal energy, et cetera. And a very small fraction of that is available to us in terms of food. So this is, again, a fundamental challenge. We've improved feed conversion ratios over the years, but there's only so far you can take this paradigm. It's not simply this kind of frustrating thermodynamic inefficiency. There are also very, very serious other kind of externalized harms associated particularly with industrialized animal agriculture, which is the most efficient, but relies on this intensification and concentration of large numbers of these animals. So it's a contributor, as we've known for many years now, to every major environmental problem at every scale from local to global. Finally, there are all sorts of public health threats and considerations associated with animal agriculture. Again, we've heard this teased multiple times throughout this conference, concerns about antimicrobial resistance, zoonotic disease emergence. There's a ton of literature in the public health space on some of these threats. I've seen some studies indicate that the risk from the next large pandemic or outbreak, which very well could be a zoonotic disease, is a greater threat than climate change in the near term. So none of what I've said here is probably news. We've known about these risks for quite some time, and increasingly so, and I think it's becoming more and more prevalent in consumers' minds, which is important. But the fact is that our meat consumption really has not declined. In 2017, the US had the highest per capita meat consumption of any year prior. I haven't seen final numbers yet for 2018, but it was on projection to be even higher. So if that's true in the US, we know that per capita meat consumption is the highest it's ever been across the entire globe. So this is a very serious challenge. The solution I'll put forward to you is not trying to, bang into consumers' heads or put policy incentives in place to try to reduce meat consumption, because we've seen those meet with limited success. The solution is to develop new products that offer consumers that sensory experience they're looking for when they're craving meat, but that have a much lower resource burden and that allow us to avoid some of these externalized harms and risks attendant with industrialized animal agriculture. So the two kind of case study solutions that I'll talk through today are plant-based meat and cell-based meat, which we've heard referenced multiple times, sometimes with different names. The nomenclature is a really robust and interesting area of discussion in the cell-based meat field. So when I use the terms clean meat, cultured meat, cell-based meat, that's all the same thing. So we'll define that in a moment. But first I want to talk about plant-based meat, because I think this is actually a really exciting area that gets a little bit shortchanged in this discussion because it's maybe not as immediately sexy from a technology perspective, but there's so much untapped potential in the plant-based meat realm that I think it's really worth highlighting here. So first, let's just define what we're talking about when we say plant-based meat. Plant-based meat products are structured products that have that same kind of structure, fibrous texture, sensory appeal of a meat product, but derived from ingredients that are either plant-based proteins, or folks will often lump other kind of alternative protein sources into this sort of umbrella term of plant-based meat. So that might include things like fungal-based ingredients that often exhibit sort of inherent fibrous structure and so forth. So again, this is not something like tofu. These are products that are really intended to give a similar experience to meat, but made from alternative protein sources. What I see when I look at the plant-based meat landscape is that all across kind of the value chain of making these products, we're seeing new technologies unlock whole new kind of fields of opportunities. So here's kind of the 30,000-foot challenge that we're faced with when we're making plant-based meat products. You're starting from plant proteins, which tend to be storage proteins, right? Often derived from something like a bean or a seed of a plant. So they tend to be, pretty globular, self-contained proteins, and asking them to act more like fibrous proteins, fibrillar proteins that you would find in muscle tissue, which is a very different structure. So this really places kind of a burden on the functionality. And there's a number of different ways that you can go about essentially coaxing this functionality out of these plant proteins. And there's opportunities all across the board. So, you can look at everything from protein sourcing, what's the inherent kind of set of properties of the proteins that you choose to use in this end application, through how you're isolating that protein, how you're further processing that protein, how you're formulating your final product to give you that complete kind of sensory palette and experience, and so forth. So we'll delve into these just a little bit. I just want to touch, again, at a high level for the sake of time, on some of the ways that we're seeing new technologies really open up R&D in this sector. So here's just kind of a graphical depiction of sort of large categories of technologies that feed into developing better plant-based meat products. And I'll just step through each of these except for distribution. I put supply chain and distribution on here just because I think this is another really exciting but also challenging aspect of looking at increased market share of these plant-based meat products, is that they have a whole different supply chain associated with them from conventional meat. And so I think we need to be looking proactively at what might be future ingredient bottlenecks and so forth as we're projecting this scale up. On the crop analysis and optimization side, again, this is really looking for that ingredient sourcing perspective. How can we develop plant crops that are kind of optimized for this end application in mind? A lot of the crop breeding and engineering and adaptation has been focused more on kind of broad agronomic traits historically, so looking at things like yield, harvestability, and so forth. Now that we've got a whole suite of new tools to get much more rapid innovation in terms of these breeding timelines and genetic information to get much higher resolution regarding, which specific traits or markers are associated with qualities that you're looking for in the crop. We have the opportunity to actually start optimizing specific lines or strains for given end applications. And we've seen a number of startup companies emerge to do this. To have say a wheat strain specific for baking and a soy strain specific for making fibrous plant-based meat products, which is a distinct end application from something like animal feed. So I think this is a really exciting area. For the raw material sourcing and optimization, this is really, refining or enriching those raw materials. So starting from, say, a whole plant flour and enriching for the fraction of that has not only higher protein, but enrichment for the types of proteins that give you that functionality you're looking for. And then finally, when it comes to the composition, formulation, this is where we've seen a lot of innovation, especially in startup companies that are working on developing plant-based meat products. Really, expanding the palette of ingredients that they're looking for. A common example is Impossible Foods using leg hemoglobin to give that kind of meaty, metallic flavor. So a lot of innovation happening here as well. And then just as a kind of overarching point that I think emerged in a couple of these, but this is really inherent throughout a lot of the technologies that we're seeing applied here, is a reliance more and more on large data sets to really inform all of these aspects, to improve our iteration speed in formulation, to give us more quantifiable measures for some of these attributes rather than relying on things like sensory panels, et cetera. I think this can really catalyze much more rapid innovation in the field. Now I'll delve into our other friend, CellBased Meat. Again, we've heard this teased several times. This is really up and coming and just emerging. So plant-based meat, of course, is on market, relatively low market share. Right now it's at about 1% of the total meat market in the US. CellBased meat is not yet on market. Some folks have tested it in kind of private tastings and so forth. I'm happy to say I've been one of the people who's eaten it, but it's not available on market yet. So this really is leading edge emerging technology. So let's define it. What is cell-based meat? Again, clean meat, cultured meat, in vitro meat. That term is kind of out of vogue now, but these are all referring to the same thing, which is basically producing meat without the whole animal, growing meat from the level of the cell. So relying on a long track record of expertise mostly from the biomedical fields and tissue engineering fields of working with cultivating many different types of animal cells in culture, and then saying, can we take a food production perspective to that and bring down some of those price points and look at going to larger scale with this technology to produce products that, for version 1.0, hopefully recapitulate the aspects of meat that we know and love from conventional production, but I think ultimately give us the power potentially to have even more fine-tuned control over that process, to really be able to dictate the parameters from a sensory perspective, texture perspective, nutritional perspective, and again, as I'll tease what Richard said, make products that are actually better than what we get from animals in nature. I'll give just kind of a high-level overview of what production for these products might actually look like at scale. So there's a few different stages. The first is the initial cell line derivation. So again, the unit of production here is genuine animal cells from whatever species you're talking about. You can do it for poultry, you can do it for fish, you can do it for cows, for pigs. You could even do it for exotic animals that we don't currently farm domestically. It's the same process and relatively similar kind of cell requirements when you're looking at that unit as the cell of production. So you derive your initial cell line. You want a cell line that behaves robustly in these culture environments, that you can get to predictably go to the desired final cell types that you're going for, which is predominantly muscle cells, but also fat cells, also cells that contribute to the connective tissue part of the muscle for texture. So once you've got your established cell line, the industrial scale process itself will likely look kind of like a two-phase process. The first phase is cell proliferation, so simply going from a small starting cell number, capitalizing on this beautiful biological principle of exponential growth, 1 cell to 2, 2 to 4, 4 to 8, and so forth, and just expanding that number of cells. And then the second stage of the process is to ask the cells to make a little bit of a metabolic shift from this kind of instruction manual that says just grow and divide as quickly as you can, to saying, okay, now seed onto a scaffold, so a 3D structured kind of support that kind of defines that spatial arrangement, and start to mature into extended muscle fiber cells or into engrossed adipocytes that are full of all of the fats that we expect in our meat products. So at the end of this process, you can have a product that really does have all of these final cell types integrated, ultimately potentially some degree of very fine resolution control over the arrangement of those types of cells within a product. Imagine if you could, for instance, dictate exactly what the marbling pattern would look like in your steak. And it's possible to imagine that based on what we know about scaffolding materials and their kind of biomechanical influence on cells around them. I'll highlight a couple of the sort of world firsts, and I'd like to bestow upon you an appreciation for how quickly this field has grown in just the last couple of years. So this kind of concept, why couldn't we just grow meat straight from the cells, is not a new idea. It's been around for a long time. A lot of people reference an old Winston Churchill essay from the 1930s that basically predicted that we'd be doing this. He said 50 years hence, so he was a little bit off the mark. But it's not a novel idea. What is novel is the amount of activity that's been happening in this sector in the last couple of years, due in large part to some really fundamental advances, again, kind of on the biomedical cell culture side, that suddenly take this from sort of thought exercise or interesting idea into the realm of possibility. So in 2013, we saw the very first public demonstration that this was possible, and so that was Dr. Mark Post in the Netherlands. He grew a burger patty just from single strands of bovine muscle tissue grown in culture. Within just the last 2 years, we've now seen prototypes of pork, of poultry, of fish, and we've seen an absolute explosion in terms of the landscape of companies operating in this space. So as of just the end of 2016, so barely over 2 years ago, there were arguably 4 companies in this space. Memphis Meats is actually Mosa Meat is Mark Post's company in the Netherlands. Memphis Meats is a San Francisco Bay Area company. Modern Meadow is based in New York. They started making meat, but since 2016 have actually pivoted to other animal products such as leather. And then Super Meat is a company based in Israel. So we had kind of a smattering of interest around the world a couple of years ago. What's happened in the last 24 months has been an absolute explosion. There are many more companies than I even have here. There's, by our latest count, about 3 dozen. That we're aware of, some of them still in stealth mode, representing close to a dozen countries around the world. We've now seen companies pop up in Singapore, in China, a couple in Canada, so really widespread interest. And a lot of these teams are bringing really interesting perspectives. Some of them are coming from the food industry, from the meat industry even. Others are coming from biomedical science and more kind of traditionally the disciplines that have this type of expertise. So it's been a really exciting, evolving landscape to watch. We have the same kind of mind map, so to speak, of the various technological elements that are critical for this field to come to fruition. For the sake of time, I won't step through all of these. We have plenty of resources and white papers and so forth that I'd love to point you towards if you want to hand me a card at the end. But I think there's a lot of opportunity to kind of blend insights from these sort of higher end, smaller volume applications of cell culture, like biopharma, with insights from the food industry and a long history of fermentation for food appropriate ingredients to kind of bring to bear here and find that sort of middle ground where this is economically feasible, has validated safety, et cetera, and can capitalize on these multiple disciplines at this intersection. I want to end by just kind of making a point about, again, what an exciting time it is in this field and why I think there's really compelling reason for folks to get involved, whether from an R&D perspective or from a larger business strategy perspective. So here I'll step back and kind of talk about the meat alternatives field writ large. So here plant-based meat and cell-based meat together. So if we look at just investment into plant-based and cell-based meat companies, as well as companies using these approaches to make dairy and egg analogs, we've seen obviously a very large uptick in terms of number of investments and the dollar value of those investments. Depending who you are in the room and what company you work for, 1.2 billion is either a lot or a little. But I think, the names of some of the companies that have been involved from an investment and strategic partnership perspective are really quite compelling here as well. I think it's clear that a lot of folks, everyone from kind of feed and food ingredients to folks directly in the meat industry kind of sees the writing on the wall here, and they're looking to diversify their offerings in alignment with what consumers are asking for. So again, across both plant-based companies and cell-based meat companies, we've seen investments from major meat companies, including Tyson, Cargill, PHW, one of the largest poultry producers in Europe, as well as from big food. So folks like Kraft Heinz and General Mills and so forth, hopping into this space very, very fervently and deliberately. Having said that, even though we have these really substantial players getting involved and what looks like a lot of investment if you're looking at historical trajectory, the point I want to end on is that this is merely a drop in the bucket relative to other sectors where we've seen really massive transitions from kind of the old way of doing business to much more sustainable approaches that truly are starting to revolutionize our impact on the world. So I pulled these spheres just as a graphical depiction of another industry that I think we've seen gone through this transition and is still going through it, which is the energy industry. So these spheres represent global R&D investment into just these single categories of renewable energy in a single year. This happens to be 2011. By contrast, total combined R&D across all meat alternatives, I'm talking about plant-based meat analogs and cell-based meat, across all years, I put in the range of about 1 to 2 billion. So somewhere between the very smallest circle and the next smallest circle. So I think there's massive opportunity to kind of get in and be an early mover, an early adopter, and really push this field forward. And the amount of progress we've seen in the last couple of years in terms of the quality of these products, their penetration into new markets, new consumers, has really been happening on this shoestring budget. And it's really exciting to think about how we can catalyze this to happen much faster with greater involvement. So the key takeaways I'll leave you with, we're seeing new technologies unlocking opportunities across every single part of the value chain, supply chain, production methods, et cetera, of this next generation of meat products. Two of the most exciting case studies, I think, here are plant-based meat and cell-based meat. One is sort of, on-market demonstrated success rate. We're seeing growth of, 20 to 25% year over year in the plant-based meat market, whereas cell-based meat is really up and coming, and we're looking at proxies like investment and number of startups and involvement of key players in that industry as our kind of harbingers of progress there. And then finally, even though there's been a lot of activity and interest, there's still substantial room for continued innovation. And so I'm always thrilled to be in front of diverse, multidisciplinary audiences like this, because I think probably for everyone in this room, there's something they can contribute from a technology perspective. So thank you very much for your time.